In this question, we're told to suppose a simple random sample of size n equals 10 is obtained from a population with mu is 63 and sigma is 17. So that's the population's mean and standard deviation. And first off, we're asked about the shape of the distribution. So what must be true about the shape? So I just grabbed this screenshot from our text, the related interactive assignment, that tells us about the shape of the sampling distribution of the sample mean, x bar. So if the random variable x is normally distributed, then the distribution of the sample mean is also normally distributed. So when you look at your choices, what must be true regarding the distribution of the population, it must be normally distributed. And then up next, you're asked to assume the normal model can be used and calculate some probabilities. Okay, so here we're asked to calculate the probability that x bar is less than 67.3 and this one greater than or equal to 64.6. So for this, I'm going to use the calculator. One of the kind of intermediate steps that we do here is we first determine the mean and standard deviation of the sampling distribution x bar. And again, took another screenshot. And here's those two relationships. So if we know the mean of the population, then the sampling distribution mean is equal to it. That's simple enough, right? The difference comes in with the standard deviations. So if we know the standard deviation of the population, to find the standard deviation of the sampling distribution, we take that population standard deviation and divide by the square root of the sample size, n. So that's what you see in this next piece here. We were told that the mean is 63, and notice that the mean of x bar is also 63. The difference is sigma. If the standard deviation of the population is 17, then the standard deviation of the sampling distribution of the means is going to be 17 divided by the square root of the sample size, which in this case is 10. We need those two values to then turn to our calculator to find these probabilities. To do that, we'll go to second vars. We're going to select number 2 for normal CDF. The first one is asking for a less than statement, so I'll just leave the lower bound like you see here. The upper bound will be 67.3. The mean, remember, is the same as the population mean, so I'm going to just use 63. Sigma, or standard deviation here, is different. So that's going to be 17 divided by the square root of 10. And I can just type it in like this. I don't have to go to the side and calculate it and then come back and put it in. The calculator will handle all that for me. So I paste, and that's how you see you can obtain that probability, 0.7881. Likewise, let's do the next one, because that's going to be just a really quick change. This is a greater than statement. And remember, because this is a continuous distribution, then I do not have to concern myself with greater than versus greater than or equal to. Unlike that binomial approximation piece, remember that we did in the last chapter. My upper bound, let's use 1E99. Everything else stays the same. And again, we arrive at 0.3830 when we round.